So today we will discuss about the application or the importance of Kc. Application or importance of Kc. Now basically what is Kc? As we all know, Kc is equilibrium constant. Basically Kc is a numerical value which shows us the concentration of the product and the reactant in a ratio at equilibrium, right? Okay, there is another term known as QC, which is known as quotient reaction or reaction quotient, right? Quotient reaction or reaction quotient, which is basically it shows us the concentration of product upon concentration of reactant. Like Kc shows us the value, like it's the ratio, obviously it shows the value at the equilibrium, but this shows us at any point or at any time except equilibrium. At equilibrium we have Kc, but the time course rather than the equilibrium point, the value which comes towards us, that is basically quotient reaction. Basically we have to determine the equilibrium, right? Okay, first of all, that we have a reaction in which A it's converted into B. Consider that here the concentration of A is 100. The concentration of A is 100. Now the concentration of B will obviously be 0, right? So at first obviously the concentration of the product, which is B, will be 0 because here the concentration of reactant is very high, right? But after some time here the concentration will be 80, here will be 20, right? Here will be 70, and here it will be 30, here it will be 60, and here will be 40. At the point when the concentration of product will be 50 and the concentration of reactant will also be 50, that point is known as equilibrium point. Like the concentration become like constant, right? So at this value, when the concentration is not constant, we will calculate Qc, but at the equilibrium point we will calculate Kc. After this, when this become 40, it will become 60. When it will become 30, it will become 70. When it will become 20, it will become 80. So at this point too, like equilibrium is not there, right? So we will calculate Qc. Now the formula is same. Kc, Qc both have the same formula, which is product upon concentration according to the law of mass action, right? And we have studied this law of mass of action. If you haven't studied, you can watch my previous video in order to clear your concepts, right? So here it is. Now let us find the, in order to determine the direction of the reaction, let us determine the direction of the reaction. Direction of reaction. What if the value of Qc is greater than Kc? What will happen? Okay, we know that Qc is equal to the product upon reactant. When the Qc is greater, it means the product is greater. If the product is greater, obviously, in order to acquire the equilibrium, the reaction will proceed to the backward. So here it will be backward reaction. There will be backward reaction. A will be converted into this to B as the product concentration is high. Right? What if Qc is is less than Kc? The value of Kc is greater than the Qc. It means that here Qc, we will observe Qc in all the cases, right? So here basically if Qc is less, it means the product concentration is low or less. So the reaction will proceed to the forward side. So there will be forward reaction. Product is low, there will be forward reaction. But what if the value of Qc is equal to Kc? It means it is equilibrium. It is equilibrium point, and the rate of forward reaction is equal to the rate of backward reaction, right? Now let us find us the extent of the reaction, like the limitation of the reaction. To extent of reaction. What is the extent of reaction? What is the limitation of our reaction? basically if the value, like number 1, if the value of Kc is very large, Kc is very large, the value of Kc is very large. Now what will happen, basically we know that Kc is large, it means the reaction is almost completed, reaction is almost completed. Okay, Kc is large, we know the formula of Kc is equal to product upon reactant, right? So Kc is large, obviously product will also be large because they both are directly proportional to each other, right? If like reaction is almost completed and product is stable, right? Now if the value of Kc is very small, where Kc is very small, then it means the reaction is not completed, reaction is not completed, and the reactant is stable. Reactant is stable and product is not stable. Third is like when the Qc is equal to Kc, or you can say the Kc is equal to 1. Okay, Kc is equal to 1 at which state? At equilibrium state, means the equilibrium has been acquired, and here the reaction is neither completed nor incompleted. Reaction is neither completed nor incompleted. Reaction is neither completed nor incompleted, right? And here one more